Hi class, in this video we want to move into section 1.4 and it's talking about differentiation using limits of different quotients. So if you remember from a previous lecture, what we saw the difference quotient was f of x plus h minus f of x over h. And what this was is this gave the average rate of change from the point basically x f of x to x plus h comma f of x plus h. And so what this was here is at the end of the lecture I kind of hinted at, look, well, what we want to do is use this difference quotient to help us find the slope of the tangent line to the graph at a point. So what we do there is we look at it by looking at the limit as h goes to 0, like what happens. All right, so let me kind of put a visual to this so that you can see. So suppose we have this point P here. And what we want to do is we want to find the slope of this tangent line. So this line right here that's denoted with a T, okay, this is the tangent line. We want to find the slope of this tangent line at this point here. Well, the way I initially described this to you many lectures ago was like, well, look, we can't. You need 2 points on a line to do this, right? So you would pick like a point Q1 up here, and you would use that secant line to estimate the tangent line. Well, you could do better. You could get closer and closer and closer here. So what you're doing as you're getting closer and closer and closer and closer and closer with your second point, you're looking at the value of h goes to 0. Okay, so what you're doing here now is, you can't have the second point be the same point because then you get a delta x and h here of 0. So instead what you do is you look at the limit as h goes to 0. So the slope of this tangent line is given by the following. M is equal to the limit as h goes to 0 of our function f with x plus h minus the function without any plus h in here, minus f of x divided by h. This limit is also called then the instantaneous rate of change of the function at that point. So the slope of the tangent line this slope of this line t is the instantaneous rate of change at that point x. Okay, so this right here, the slope of this tangent line, that's the instantaneous rate of change of the function at x. So you could also kind of think of this being as the slope of the graph at that point, if it's the instantaneous rate of change at that point. So this gives us to something called the derivative. And this is one of the most important topics of our class. And so the reason I say that is because we'll be talking about the derivative every single day of the lectures going forward. Very rarely will there be a lecture where I don't reference the derivative. So it's an incredibly important concept. So for a function, okay, y is equal to f of x, its derivative, so what we call the derivative of a derivative at x is the function which we denote as this. F, and this up here is prime. This is read as f prime. And it's defined by this, okay? The derivative function f prime of x is just equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. And this is provided the limit exists. So if f prime of x exists, then we say that f is differentiable at x. So we can find the derivative at x there. And we sometimes call this f prime of x the derivative function. And what this function does, this function, f prime of x, gives the instantaneous rate of change of the function f of x at that value x. Okay, so what it'll do is we're going to find this limit here and this new function that we have, and I promise as I go through the examples this is going to make sense to you. What it's going to do is it's going to give the slope of the tangent line at any x value. And that slope of the tangent line is the instantaneous rate of change of that graph. All right, so I find now that we kind of have an understanding of it. Like, okay, this, if I can evaluate the limit as h goes to 0 of the difference function, then the difference quotient, then we have the instantaneous rate of change of the graph, the slope of the tangent line at that point. Let's do some examples just so we can see how this works. And if you'll notice in the slides here, I'm going to work everything by hand. So as you're watching these lectures online, let's I encourage you to follow along with me. So I've got this function, okay, f is equal to x squared. And I want to find f prime of x. So I want to find this derivative function, okay? And then what I want to do is I want to find the derivative function. I want to evaluate it at two values, -3 and 3. Okay. So how to find f prime of x, this derivative function? Well, f prime of x is equal to the limit as h goes to 0 of the difference quotient. Okay, sorry, it's a little sideways there. F of x plus h minus f of x over h. Sorry, it's a little tilted there. Okay, so what I have to do then is I have to find the limit as h goes to 0. What I have to do is I have to take x plus h and plug it into my function. So x plus h gets plugged in for x. So this is x plus h squared minus f of x. So minus my function f of x. Well, what is that? That's just x squared all over h. So what I'm going to have to do now is I'm going to have to work some algebra magic here. So this is the limit as h goes to 0. I'm going to have to rewrite this. This is x plus h times x plus h minus x squared all over h. Okay, well so this now becomes the limit as x goes to 0. So I have to FOIL this out, right? Like this is x squared, x times h is xh, h times x is xh, so that gets me plus 2xh, plus h times h gets me h squared. And then don't forget this minus x squared over here, all over h. Well, look what happens. X squared minus x squared, those are going to cancel out. And you're left with the limit as h goes to 0 of 2xh plus h squared over h. Okay, so remember, to evaluate a limit, you're just going to plug in the value. So I'm going to plug 0 into this, and you would get 0 over 0, which is indeterminate form, which means there's something you can do to evaluate this. So what I'm going to do is I'm going to notice I can factor out an h in the top in the numerator. So this is h, 2x plus h all over h. Well, look, what happens? The h's cancel. And then this is what I'm finally left with. F prime of x is equal to the limit. I'm sorry, I think I wrote x goes to 0. Here it was h. Limit as h goes to 0, sorry about that, of 2x plus h. Well, when h goes to 0, this just goes to 0. 2x here, there's no h in it, so it's just equal to 2x. So this is just 2x plus 0, or just 2x. So this is what's going on here. This f prime of x, the derivative function, is equal to 2x. So if you give me the x value, I can tell you the instantaneous rate of change, or the slope of the tangent line to the function at that x value. All right, so now let's continue. Let's find f prime of -3 and f prime of 4 and talk about them. We'll just again recall that f prime of x here was equal to 2x. F prime of -3, well, I'm just going to plug in -3. This is 2 times -3, gets me -6. And then f prime of 4 is just 2 times 4, which gets me 8. So this is the slope of the tangent line of the graph at x is equal to -3, and this is the slope of the tangent line when x is equal to 4. Let me just kind of like show you this, Okay, so you can see how this is working. All right, so what I'm doing a rough sketch of here, forgive me that it's super rough. This is the function f of x is equal to x squared. This is my original function. When x is equal to -3, this is the graph right here. And what we're saying is the slope of the tangent line, look, the slope of the tangent line at that point is equal to -6, which totally makes sense because it's sloping downward. And then when x is equal to 4, what we're saying here is this is the tangent line to the graph there. The slope of this tangent line is equal to 8. And let's just do an extra one. Let's find f prime of 0. Well, that's 2 times 0. That's 0. And look, here's when x is equal to 0. And the tangent line is just the x-axis right there, which does have a slope of 0. So this function here, okay, this derivative function, this f prime of x, it's giving you the slope of the tangent line, okay, at that point. Let's do some more examples. So what we're going to do in this section here is we're going to find the derivative function here, this f prime of x, with the limit process. And you're going to notice that some of these problems, it's a lot of algebra work. And I'm going to show you the tricks in later sections, but let's just focus on evaluating the limit here. Okay, so for this one, for f of x is equal to x cubed, let's find the derivative, f prime of x, and then let's evaluate it for -1 and 1.5. All right, so just remember, f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. All right, so my function here is the cubic, okay? So we got the limit as h goes to 0. Now it's x plus h cubed minus f of x, which is just x cubed, over h. So I put up the formula for the cubic here just so you can see it. So it's a plus b cubed is equal to this. And so I'm just going to replace a and b with x and h here. So this is the limit as h goes to 0. So this is a cubed. So this is x cubed plus, and it looks like it's 3x squared h plus 3x h squared plus h cubed, and then minus x cubed, all over h. Well, look, this is amazing. X cubed and x cubed go away. What do these all have in common? They all have an h, so let's factor that out, the remaining terms. So this limit as h goes to 0 of h of 3x squared plus 3xh plus h squared all over h. Well, look what's going to cancel out. So limit as h goes to 0. This is 3x squared plus 3xh plus h squared. Right? So as h goes to 0, nothing happens to the 3x squared. Plus 3x, you can just plug 0 in for h. Plus 0 squared. Well, look, this goes to 0, this goes to 0. And f prime of x here is just equal to 3x squared. All right, so then what we want to do is we want to find the slope of the tangent line at -1 and at 1.5. So again, just recall f prime of x is equal to 3x squared. So the slope of the tangent line to this graph at -1 is equal to 3 times -1 squared. Well, -1 squared is 1 times 3 is 3. And f prime at 1.5, well, you're just going to plug this in. This is 3 times 1.5 squared. I believe 1.5 squared gets you 2.25. And then 3 times 2.25 gets you the slope of the tangent line then is 6.75. Okay, so a little bit of algebra here is to evaluate these limits. So any of the problems that you would get on your homework, you're going to see that it's just going to involve an algebra trick to solve here. Like here, I had to factor, or I had to distribute this out, and then I had to cancel the x cubed, factor, cancel out here, and then evaluate the limit. All right, let's do a harder one. So let's take some rational function here. So f of x is equal to 3 over x. And what I want to do is I want to do three things. I first want to find f prime of x. Then I want to find f prime of 2, so the slope of the tangent line at 2. And then I want to find an equation of the tangent line to the curve when x is equal to 2. All right, so a lot going on here. All right, so the first thing we're going to do is let's find f prime of x. So I want to find f prime of x for f of x is equal to 3 over x. So f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. So this is the limit as h goes to 0 of 3 over x plus h, because I'm plugging that in, minus 3 over x, because that's my f of x, all over h. So what you're going to have to do is you're going to have to combine this. So like the LCD here is x times x plus h. And I did a very similar example to this in the previous video, so you should remember that, this process. So the limit as h goes to 0. Well, this is 3x over x plus h minus 3 times x plus h all over x plus h, and then divided by this h. So look, now you got to combine this, and it's just got to be careful of your algebra here. So this is the limit as h goes to 0. This is 3x minus 3 times x, so minus 3x, minus 3 times h, so minus 3h, all over x plus h, still divided by h. Well, look what cancels. This and this cancel. So the limit as h goes to 0 of minus 3h over x plus h over h. So think of this h as h over 1, and it's keep, change, flip. So it's the limit as h goes to 0 of minus 3h over x plus h times 1 over h. Well, look what cancels, right? Those cancel. So you're at the limit as h goes to 0 of minus 3 over x plus h. Well, so here's what you can do. You can just plug 0 in for h. Okay, so you're left with minus 3 x times x plus 0. Well, this just ends up being minus 3 over x squared. So this is my derivative function. F prime of x is equal to minus 3 over x squared. So now the next part said, let's find f prime of 2. Well, you can just take that 2 and plug it in. Well, 2 squared gets you 4. So the slope of the tangent line when x is equal to 2 is minus 3/4. Well, look, I've got the slope. All right, so now what I need to do is I want to find an equation of the line tangent to the graph when x is equal to 2. So let's find equation of tangent line to graph at when x is equal to 2. All right, so I'm actually going to use the point slope formula. It's y minus y1 is equal to m times x minus x1. Well, I know the slope, okay, when x is equal to 2. That's what my derivative function told me. So I need the point, right? So to find the point, you're just going to take 2 and you're going to plug it into your original function. And when you do, you get 3 over 2 which is just 3/2 here. So there's my point. So it's y minus y1, which is 3/2, is equal to the slope minus 3/4 times x minus 2. So just distribute here. So this is y minus 3/2 is equal to minus 3/4 x. Negative times a negative is positive. This 2 will simplify the 4 to a 2, so it becomes plus 3/2. Add the 3/2 over. Well, 3/2 plus 3/2 gets you 6/2, or 3. So this is my equation of the tangent line. So a lot going on in this one here. We use the limit here to find the derivative function. Then we found the slope of the tangent line at when x is equal to 2. And then we found the equation of the actual tangent line, because we could find the point where the tangent line just touches the graph and its corresponding slope. All right, so I just want to end this lecture talking about where a function is not differentiable, because not every function is differentiable at every single point. So a function f of x is not differentiable at a point x is equal to a when there is a corner, like a sharp turn like this, or even these here. Whenever there's this like sharp turn, okay, the function is actually not differentiable there. It's differentiable everywhere else on the graph, just not at these sharp turns. Function f of x is not differentiable at a point x is equal to a where you get a vertical tangent line, right? Because what's the slope of vertical tangent line? Slope is undefined. And then finally, a function f of x is not differentiable at a point x is equal to a if it's not continuous there, right? Like if you look at this graph, this function g of x, it's not continuous at -2, so the function is not differentiable there. All right, class, I hope this video helped, and you should be able to tackle your homework problems for this section.